Hello, this is Unit 8, Lesson 5. This is talking about indirect measurement with word problems. Indirect measurement is just simply a way of measuring things that are not convenient to actually measure directly. Okay, if you're going to measure directly, then what you would do is you would use something like a ruler and place it next to the object that you want to measure. Some of these things are just not what you want to try to do. Okay, one of the things that's very difficult if you tried to measure the distance across the Grand Canyon with a tape measure. Can't do that very well, but you can do that indirectly using geometric processes, and that's something that they do quite frequently. Okay, one of the things that was done this way is there was a family that spent 150 years with two or three different generations that actually that mapped the whole country of France. And this was something that was done many times indirectly because that's how they estimate the heights of mountains and so on and so forth. Okay, all right, so let's take a look at this. Many things in science and engineering are measured indirectly because a direct measurement is impractically complicated or expensive. For example, one of the things that could be if you wanted to measure the temperature of a very hot furnace, a very expensive thermometer could be built that could withstand the intense heat of the furnace. Once you put that in there, that would be a direct measurement of the temperature. However, the expense that you were going to with this might not be very productive because that would mean that would be a lot of expense that you would have to go to every time you built a furnace. So possibly a better way to do it would be to take a solid iron ball that you know what the weight of it is, heat it in the furnace so that it gets the temperature of the furnace, and then you drop it in a bucket of water or a large vat of water and see how much of the water goes away. Measure the water before you drop it in, measure the water after it finishes boiling. You'd have some pretty good idea of exactly what the temperature could be because you could determine what the formula was that would predict how much heat would be necessary to cause that much water to boil off. Okay, so that's one of the things that you can do. Okay, what we could do here, and one of the things that we use quite frequently with this is using overlapping triangles that will allow you to estimate things like the height of a building, the distance across a river or a lake, and all these kind of things. So one of the ways that you could measure a height of a building directly is you could climb to the top of the building, tie a weight on a string, and then lower it until it touched the ground. The length of the string could then be measured with a tape measure. That would be a direct measurement. Wouldn't be very practical, but it would be a way to do it. Okay, an indirect measurement of the height of the building is illustrated in example 1. It uses ratios that result from similar triangles. So here's what we got. And the two triangles are overlapping, so that gives us some idea because the line of sight is what tells us that the two of them are similar. So a 32-foot tall tree is located near a building. How high is the building given the distances in the drawing? The length of BC is the height of the tree and the length of DE is the height of the building. So here's what our diagram looks like. So we're 25 feet away from a tree that we know is 32 feet tall, and if we line up with the top of the tree and the top of the building at the 25-foot mark, we know that they're 60 feet from the tree to the building. So this way we have two overlapping triangles, and one of them has a length or has a leg of 25 feet and 32 feet. The other one has a leg of 85 feet and an unknown length. So we're going to use that using the proportions that we talked about earlier in this chapter, and this is what we've got here. This is we redraw the triangle so we can see what we're directly looking at. Just a way to organize your thoughts. So once we get this, we set up our proportion, which is 32 to x is equal to 25 to 85. Okay, so we have the height of the tree over the height of the building is equal to the length of the distance to the tree and the length of the distance to the building. Okay, cross multiply gives us 25x is equal to 32 times 85. That becomes this. So we're going to have, once you place that in the calculator, you can put it directly in the way that it was written in the previous step. That gives you an approximate length of 108.8 feet. So the height of the building is about 11 stories, so that'd be approximately 108.8 feet in this case. Okay, example 2. We have Billy Bob. He's a 6-foot man and he's standing 7 feet away from a small mirror lying horizontally on the ground. Looking down at the mirror, he sees a reflection of the top of a flagpole whose base is 20 feet on the other side of the mirror. How tall is the flagpole? Consider the mirror as a point reflecting the same angle from the man's eye to the top of the flagpole. Okay, so this is what the situation would look like. So we have two similar triangles. Okay, one of the things we know is we have a right angle here at the flagpole. We know we have a right angle here at the man. The angle of incidence of his sight to the mirror is the same as the angle going up. Okay, so this means they're similar triangles, so we can compare corresponding distances. So since we know the man is 6 feet tall, the distance to the mirror is 7 feet, and we know the distance from the mirror to the flagpole is 20 feet, we can find out what the corresponding height of the flagpole is by using a proportion. So what we have here, and once again we're going to redraw the triangles to organize our thoughts. And so we now have 6 to x is equal to 7 to 20. Notice once again, height of the man to the height of the flagpole is equal to the distance to the mirror from the man over the distance from the mirror to the flagpole. Cross multiply and divide gives us 7x is equal to 6 times 20. 7x is equal to 120. So x is equal to 120 divided by 7, which is approximately 17.14 feet. Okay, this pretty much concludes this lesson. If you have any questions, be sure you bring them to class. Write them down while they're still fresh in your mind. Bring them to class tomorrow, and we'll be glad to discuss them with you before we start any work. Thank you very much. Goodbye.